This is a word problem, and it's dealing with rates of change. So the members of the Blue Boar Society, they rent the pavilion every year for their picnic, and they divide the price equally among all the members. So right now there are 65 members, and the pavilion rents for $250. It's $250 a year. The cost is increasing at a rate of $10 per year. So the cost is $250 plus $10 every year. And the number of members is 65, and that is increasing at 6. So we have 65, and that's increasing at 6 members every single year. So what I'm trying to find out is what is the current instantaneous rate of change of each member's share of the rental fee. How much is it changing right now, this particular current year? Well, I'm looking at this, I'm saying, I'm going to define a function here. I'm going to define a function C for the cost per member, and that is, right now, it's $250 divided by $65, but it's changing all the time. So it's really 250 plus 10x divided by 65 plus 6x. So if I went another year, it would be different. If I went 2 years, it would be different. Like if I went 1 year, the cost would be 250 plus 10, and the membership would be 65 plus 6. So it is changing. I want to know how rapidly, what is the rate of change right now in this particular year? Well, if I'm starting here at this particular year and I'm going forward, this year is year 0. That's going to help us solve this. This is, right now we are in year 0. So I need to find the rate of change of my function c. All right, well, I have a quotient here as well as some sums. And I remember that in my quotients, it's fg minus fg over g squared, and it's f prime g, fg prime. So what I have is, actually that, I should have put the c prime there, that's just c. C prime is equal to, well, 250 plus 10x prime times 65 plus 6x minus 250 plus 10x times 65 plus 6x prime. And all that is divided by 65 plus 6x squared. Isn't this awesome that we can actually do this with math? It's amazing. So c prime is equal to, well, my derivative of this piece right here, that's 0 plus 10. So that's going to be equal to 10 times 65 plus 6x minus 250 plus 10x times the derivative of this, which is just 6. And again, that's going to be divided by 65 plus 6x squared. So, again, just continuing on with some arithmetic. C prime is equal to 650 plus 60x minus, well, 6 times 250 is 1500 plus 60x. Notice my clever use of brackets so I don't lose negative signs. Divided by 65 plus 6x squared. So I have c prime is equal to 650 plus 60x minus 1500 minus, let's actually get rid of our brackets right here, minus 1500 minus 60x divided by 65 plus 6x squared. So my 60x, positive 60x, negative 60x goes away. I have C prime is equal to, well, 650 minus 1500 is negative 850 divided by 65 plus 6x squared. Well, what is x? Remember back up here? We are in year 0. So x is 0. So I can say C prime in year 0 is equal to negative 850 divided by 65 squared. So I'm going to look at my calculator, and I'm going to go negative 850 divided by parentheses 65 close parentheses squared. Enter. Negative 0.20. Negative 0.20. In other words, the cost per member is declining by 20 cents per year right at this particular moment in time. Let's check it on the calculator. Why not? So I'm going to enter the function in. There's my function of my cost. Right? Here's my cost function right here. And I just entered it into the calculator. And I'm going to go zoom 6. And there's a graph of it. So this is interesting that the cost per member actually goes down. Intuitively, it kind of surprised me because I thought since it was going up by $10 and the members were only increasing by 6, I figured it would be the cost per member would be going up. But it's not. It's going down, and I'm not going to argue with that. But what I want to know is at year 0, what is the slope of the tangent line? What is the rate of change of this function? So I'm going to go alpha f2, and I'm going to pick my n derivative function. I have alpha f4. My function is in y1. I could have written out the function again, but why waste the time? I put a comma. I'm finding the derivative for x. I'm finding it at x equals 0. I close my parentheses, and bingo, same answer. So this is a nice confirmation of the problem, graphically, calculator-wise, and algebraic.